Hello, today we'll be discussing our research investigating the mandible grip strength of the red imported fire ant. Solenopsis invicta, or the red fire ant, originally from Brazil, is an invasive species that now occupies the entirety of the southeastern United States. They're an adaptable species that can survive in many environments but thrive in warmer conditions. Fire ants have mandibles that are critical to the species' ability to harvest food, sting predators, and capture prey. With climate change impacting many ecosystems and the organisms that reside within them, we decided to research how different environments would affect their mandible grip strength. The four environmental conditions that we decided to test were a cold condition of negative 19.3 degrees Celsius, a warmer condition of 50 degrees Celsius, a simulated flooded condition using rafted ants, and then a control group tested at 25 degrees Celsius or room temperature.
We hypothesized that the mandible grip strength will decrease in colder conditions given that the imported red fire ant prefers warmer climates and have readily adapted to flooding conditions. After harvesting the ants from the Georgia Tech campus, we designed a setup capable of measuring the maximum force of the ant mandible grip strength. In this video, you can see the ant latching onto the nitrile glove stabilized on a piece of tape, and as we're pulling down, the force sensor is measuring the force of the mandible grip strength.
The ants in our control treatment were pulled at 25 degrees Celsius. The ants in the freezing treatment were placed in a freezer at negative 19.3 degrees Celsius until they were stunned, and then their force was measured. The ants in the heated treatment group were placed on a weighboat floating on water that was 50 degrees Celsius, and then their force was tested. Finally, we placed 200 ants into water to simulate flooding, let them sit there for about 5 minutes, and then we tested their mandible grip strength. Here you can see a plot of our data along with a line of best fit for each treatment group. We found that the ants in the heated treatment group have a higher average mandible grip strength than any other group. And this was confirmed after running an ANOVA and finding that there was a statistical significance between the control and the heated treatments.
Based on our data, we failed to support our hypothesis since the cold conditions did not have a significant impact on mandible grip strength. On the other hand, our data did support our hypothesis that heat will have a positive impact on mandible grip strength. Overall, our research illuminates the environmental conditions that most positively impact mandible grip strength. This in turn suggests the environmental conditions that are most favorable for Solenopsis invicta to invade in the future.